Hello everyone. In this video, I'm going to talk about the Solidity programming language which we'll be using to write smart contracts on the Ethereum blockchain. Before starting, I would like to quickly introduce myself. I'm Amrisha Kakoti and I'm working as a software engineer at Kpro Solutions Private Limited. Kpro is a leading provider in Datalake, cloud implementations, IoT, blockchain, analytics, machine learning, artificial intelligence, deep learning, and mobile application development. So without any further ado, let's get started with today's video. So the topics we'll be covering in this video are enumerations, address, and finally mappings. So let us start with what are enumerations. So enumerations comprise of predefined list of constant values. Enumerations are passed by values and each copy maintains its own values. Enumerations cannot be declared within functions but declared within the global namespace of the contract. And predefined constants are assigned to enumerations. Predefined constants are assigned to all the values in an enumeration, increasing integer values starting from 0. Now let us look at an example of enumerations. So this is a very simple contract to explain you regarding the enumerations. So this is the first line of the contract, that is pragma, and here this is the contract definition. Okay, so here this is the enumeration declaration. So here enum followed by the identifier, and we have the list of values within the curly braces, like right. So A, B, C, D, E are the values. So each of these values will have an integer assigned to it starting from 0 and increases consecutively. Okay, so A will have the value 0, B will have the value 1, C will have the value 2, D 3, and E 4. Okay, so here initially we're assigning B to this my alphabet. Then we have this function. So in this function we are assigning D to this. So okay, I'll tell you what this function will return once I deploy the contract. So I'll just walk you through what these functions are. So in this function A has been assigned. This function I have written to explain you the pass by value, and this I am assigning an integer. So let me quickly deploy the contract. Okay, so initially look at this line. So here I have mentioned the public specifier visibility, which automatically gives us a getter function, right? So here we have this my alphabet. So what should this my alphabet return? So it should return the integer value corresponding to B. So 0, 1, it should return 1. Let's check. Yeah, it is returning 1. Next, let us look at this function. Okay, so here we're assigning D and it's returning D. It should return D, that is the integer value corresponding to D. So 0, 1, 2, 3, it should return 3. Then the function name is return enum. Yep, it is returning 3. Next, let us look at this function. So we have assigned A, and here we are explicitly converting into uint. Okay, so it should return us the integer corresponding to A, that is 0. So return uint. Yep, it is returning us 0. Next, let us see this function, that is pass by value. Here I have not mentioned any getter function. So I'll show you how do we access the output in the console itself. Okay, so you can see one thing. So this is where everything goes. So I'll just clear the console. Yeah, okay, so now let us have a look at this pass by value. So once I click on this, so what should it return? It should return the integer value corresponding to E, that is 0, 1, 2, 3, 4. So pass by value, click on this, and here you can see decoded output, it's returning 4. And finally we have this assign integer. So we have assigned 2, right? So it should return 2. So let me just quickly click on this and I'll see and here you can see it's returning 2. So this is a very simple example to explain you regarding the enumeration part. Now let me go back to my slides. Now let us talk about address. So address is a 20-byte data type. They are designed to hold 20-byte account addresses in Ethereum. Address is a value type and it creates new copy while being assigned to another variable. It has a property called balance which returns the amount of ether in that account. It provides two functions to transfer ether, that is transfer and send. And it provides functions to invoke the contract function. And the functions are call, delegate call, and call code. So we'll talk more about these functions of address more in one of my upcoming videos. So for the time being, this is all about addresses. Next, let us see mappings. So it is a data structure that holds key value pairs. All keys must have the same type and all the values also must have the same type. Mapping is always saved in storage as it is a state variable. Mappings declared inside functions are also saved in storage. The advantage of mappings is that the search time is constant irrespective of the size. And we all know that arrays have linear search time. That is, the search time increases with the increasing size. Mapping is not iterable. That is, we cannot iterate through a mapping using the for loop. Keys are not saved into the mapping. To get a value from the mapping, we provide a key. The key gets passed through a hashing function that outputs a predetermined index that returns the corresponding value from the mapping. And if we want a value of a key that does not exist, we will get the default value. Now let us look at an example of mappings. Okay, so look at this example. So this is a very simple contract. So we have the first line as usual, and we have this contract definition. So here we are mapping an address variable with an event variable. And here we have a function that is payable function. This means that this function can receive ether. And the visibility I have specified as public. And here we are sending something value that is in terms of way, this one, from a particular address. So let me quickly deploy this contract and explain you what exactly mapping does. So here you can see. So I'll quickly, just for the sake of simplicity, I have created 3 accounts, okay? So here you can see, okay, just give me a second. These are the 3 new accounts that were created, and each of these accounts will have 100 ether. So let me just refresh it once so that it will show that it has 100 ether. Yeah. So yes, these 3 accounts that I've created right now, and each of these accounts have 100 ether in it. Okay. So let me quickly deploy this. So let me deploy this contract from the last account. Okay. And I'll just give the value as 67 way. And okay, let me deploy the contract from any account, and let me not put the value right now. So I'll just deploy it. And here you can see in deployed contracts, this we have send. Right, so I'll send this value from a particular account. So for example, the last account, from this last account, and I'll give the value as 67. Okay, and I'll just put send here. And for example, I'm sending another value from the second to last account, and I'm just 89 way, and I'll just give send here. Now we can retrieve what value was sent from which account. So for example, right now we sent, I guess, 89, right? It's from this account. So let me just copy this address, and I'll just put the address here. and cents, we can get back the value, how much value was sent from that account. Similarly, from the last account, we sent, I guess, 69 or something. So let me just check. What did I send? So I'll just delete this and I'll paste that account and I click on sends. Yes, we send the 67 value. Now if we pick a random account from which no transaction was made, so for example I'm picking this account from which no transaction was made, so it should return me a default 0 value. Okay, so I'm picking this, so I'm just copying this address and here I'm pasting it, and hence it's returning me a default value. So this is all about mappings. Now let me go back to my slides. Now let us have a quick recap of the topics that we have covered in this video. In the beginning we talked about enumerations, then we talked about addresses, and finally we talked about mappings. Thank you for watching this video. In the next video, that is Introduction to Solidity Part 6, the topics I'll be covering are variable scoping, type conversion, which will include implicit and explicit conversion, block and transaction global variable, cryptographic global variables, address global variables, and finally contract global variables. Kindly provide your valuable feedback in the comment section below and let us know of any topic you want us to make a video of or any issue you might be facing in your project. You may write to us at feedback@kpro.co.in. You can also subscribe to our channel if you want to learn more about technologies like blockchain, cloud, data science, ETL, data lake, DevOps, big data testing, cloud testing, etc. And you can also follow us on YouTube, Facebook, LinkedIn, Twitter. Thank you very much. Let's keep learning.